In this video, I'm going to talk about the Unit 9 review sheet questions that you guys wanted me to go over. Starting with number 3, I have y is equal to log base 2 of x plus 1. I want to graph that function. It's really difficult for me to plug in numbers into a logarithm function and see what I get for y, because y is my exponent, and logarithms are backwards of the way that I normally think about things in math. So in order to plug something into the logarithm, I would need to think of what answer makes sense, not what I would plug in for an exponent. And that's difficult to do sometimes, especially when there's transformations. So I'm going to start with, because logarithms, the inverse of them are exponential functions, I'm going to start with an exponential function, and I'm going to be able to make my way into this logarithm that I want using what I know about inverses and transformations. So I'm going to start with the parent exponential function. That's going to be the most basic function. This is the most basic function, or exponential function, with the same base as the logarithm that I want. So the base for this logarithm is 2. My parent exponential function is going to be y is equal to 2 to the x power. That's the most basic exponential function with a base of 2. My table for this, I'm going to pick values -1, 0, and 1 for x, because those are the ones that I usually pick that are most definitely going to fit on my graph. If I plug in -1 for x, I'm going to get 2 to the negative first power, or 1/2. If I plug in 0, I'm going to get 1. If I plug in 1, I'm going to get 2. From there, I'll be able to go to my parent logarithm. So that's going to be the most basic logarithm with the same base as the final logarithm that I want. So it's going to be the most basic logarithm with base 2, which is the equation y is equal to log base 2 of x. That's the simplest, most basic logarithm with base 2. This function is the inverse of this function here. And because of that, I can take the values that I got in this and flip them. So instead of having to have thought of the answer 1/2 to plug into the logarithm, I just automatically get it from the parent exponential table. I flip these values, so instead of -1, 1/2, I'm going to have 1/2 -1. Instead of 0, 1, I have 1, 0. And instead of 1, 2, I have 2, 1. Since there's a horizontal shift here, I can see I actually want to move these a little bit to the left, so I have enough space to do my horizontal shift. So I have 1/2, 1, and 2 a little bit to the left. So there's space here for me to do transformations. The only transformation that I see here is +1 inside of the parentheses. This means that I'm moving to the left one. If I move to the left one, that affects my x values if I move left or right. If I move left 1, that means I'm going to subtract 1 from all of my x's. So subtract 1 from the x's. Subtracting 1, and I'm going to end up with the final logarithm is the equation that I have here, the one that I wanted, with just that one transformation of moving everything to the left one by adding 1 inside of that parentheses. And I'm going to have -1/2, -1. I'm going to have 0 and 0, and 1 and 1. And then before I graph that, I want to plot my, because this is a logarithm, I'm going to have a vertical asymptote. I care how I'm moving left and right. That's going to affect my vertical asymptote. I'm moving to the left one, so does my vertical asymptote. It moves to the left one. I have x is equal to -1 is my vertical asymptote. I'm going to plot these points, -1/2, -1, 0, 0, and 1, 1. I'm going to connect them, making sure I don't touch that vertical asymptote. My domain for this function is going to be, I have my x values start at -1, and then that's not included, so I put a parentheses on that, to +∞. And then for my range, I know I'm going from -∞ to +∞. That's all y values are included. The next problem you guys wanted me to go over is number 6. Same concept as the last one. I want to start with my parent exponential function. So I'm starting with the parent exponential function. That's the most basic exponential function of the same base as the logarithm that I want. So that's going to be y is equal to 3 to the x power. I have same thing. The values for x to plug in that are good to plug in are -1, 0, and 1. If I plug those in, I get 3 to the negative first power is 1/3. 3 to the 0th power is 1, and 3 to the first power is 3. And then from there, I'm going to go to my parent logarithm. So the parent log is the most basic logarithm with the same base as the logarithm that I want to end up with. That's y is equal to negative log base 3. Oh, nope, that's not what that is. It's y is equal to log base 3 of x. No extra stuff, just log base 3 of x. No negative in front. And to this is the inverse of this. So to get the values or the ordered pairs in this table, all I have to do is flip the values I have here. So I have 1/3, and I'm going to leave enough space for my horizontal shift. 1/3, -1. I have 1 and 0. I have 3 and 1. The transformations that I see +4 inside, which means I'm moving to the left 4. If I'm moving to the left, it's affecting my x values, and since I'm moving left, I'm going to be subtracting 4 from my x's. Then the other transformation I see I have this negative in front, and that negative means I have a reflection over the x-axis, and everything moves upside down. For everything to move upside down, that's going to affect my y values. If you actually look at the points, if you flipped a graph upside down, the pattern would be that you're multiplying your y values by -1. So I'm going to multiply my y values by -1, and I'm going to subtract 4 from all of my x's. And then I'm going to end up with my final log, which is the equation that which is this equation. So that's my final log equation. And the table for that is going to be, I have 1/3 minus 4 is -3 and 2/3. I have -1 times -1 is +1. The next point is 1 minus 4 is -3, and 0 times -1 is 0. And I have 3 minus 4 is -1, and I have 1 times -1, which is -1. Before I plot these points, I'm going to draw my vertical asymptote. I know I care about how this is going to be vertical, so I care about how I was moving left and right. And I was moving to the left 4. So that means that my vertical asymptote is going to be at x is equal to -4. That's my vertical asymptote. Don't forget to draw your vertical asymptote on your graph. Then I plot these points, -3 and 2/3 and 1. I have -3 and 0, and -1 and -1. And then I connect to them, making sure I don't touch that vertical asymptote. My domain is, I'm starting at -4, going to +infinity. For -4 is not included. And then range is always -infinity to +infinity for logarithms. For number 23, this looks like the property that says if I raise a base to a logarithm of that same base, then the answer is going to be whatever is inside the logarithm in the exponent. So if I raise a base to a logarithm, or I have a base raised to an exponent logarithm that has the same base, the answer is going to be whatever's inside. The only problem with what I have here is that it isn't a single logarithm by itself with something inside in the exponent, and I need it to be for me to be able to use that property. I can't have coefficients. I can't have anything else. I can't have multiple logarithms. I need one single logarithm by itself. And because these logarithms have the same base, I can combine them and condense them. I'm going to do that off to the side. I have 2 ln of 6 minus ln of 12. What I want to do is I want to, first, before anything else, before I can combine, I need to get rid of the coefficients. So I'm not allowed to have coefficients. I need to move them to be exponents instead. I only have a coefficient for the first logarithm, so that's the only one I need to change. I'll have ln of 6 to the second power. So I'm raising what's inside of that logarithm to the second power, moving that moving that coefficient. And now I have subtraction in between two logarithms with the same base. So I can combine them into a single logarithm. Since I see subtraction in between, I can use division. I take the term I have inside the first logarithm, 6 squared, and I divide by what I have in the second, 12. 6 squared is 36. I have 36 divided by 12. So I have ln of 36 divided by 12 is 3. This means I have e raised to the ln of 3 power, which is 3, because ln has the same base as this base here. Its base is e. If that's not clear to you, you can always rewrite ln. Whenever you see ln, you can rewrite it as log base e. So I would have e to the log base e of 3. That's going to spit out, since I have a base raised to a logarithm with the same base, it's going to spit out what's inside of that logarithm in the exponent, and that's 3. For 26, I have log base 343 of 7 minus ln of e to the third power. For problems like this, you're told to evaluate that don't share a base in common, you probably need to simplify. In order to simplify a logarithm, you look at the base that it has and what's inside. If they share a base in common, you're going to be able to write this as a fraction or a whole number. So 343 and 7 do share a base in common. They share a base of 7 in common. If I raise 7 to the third power, I get 343. So there's two different ways that you can do this. The easiest way that you can do this is, well, what you could do is you could say, well, I have 343 raised to what power gives me 7. That's what this is asking for. That's what exponent this is asking for. It's asking for an exponent. Whenever you see logarithm, it means exponent. And I could solve this by rewriting both sides in terms of the same base. So I could write 7 to the third power raised to the x power is equal to 7 to the first power. That's 7 to the 3x power is equal to 7 to the first power. So 3x has to be equal to 1 because these exponents need to be equal to each other for the sides to be equal. That means x is equal to 1/3. So this is 1/3. I need to raise 343 to the 1/3 power to get 7, which makes sense because 7 to the third power is 343. So it would make sense that I would be taking the third root, or the cubed root of 343 to get 7. The other way that you can do this, if it's easier for you, is use the change of base formula, which means you can change to any base that you want. So I could take this and I can use that change of base formula that says I can change to whatever base I want by making a fraction and plugging in the answer into the top, so 7 into the top, and the base into the bottom, b for base, b for bottom. And if I do that in my calculator, I'm also going to end up with 1/3. So that first logarithm is 1/3, and then the second logarithm, I have ln of e to the third power. Whenever I see ln and I'm evaluating, I like to change it to log base e, so it's easier for me to see what's going on. So instead of writing ln, I'm going to write log base e. So I'm going to do log base e of e to the third power. So sorry, I changed that ln to log base e. And I can see now this is asking me, this logarithm is asking me for an exponent like it always is. It's asking me, what do I have to raise e to get e to the third power? And I need to raise e to the third power to get e to the third power, so this is 3. I'm taking 1/3, I'm subtracting 3. I'm going to end up with -2 and 2/3 is my answer. For number 30, I have a logarithm equation that I need to solve for x. When I can't solve when it's in logarithm form, I can convert it to exponential form, and I'm probably going to be able to solve it that way. So I want to identify what's my base, what's my exponent, and what's my answer. In exponential form, my base is going to be 5. My exponent is always the number that's by itself on the other side. A logarithm represents an exponent, so that logarithm is equal to an exponent. My exponent is going to be 0. The answer is everything that's inside of parentheses, everything that's inside of that logarithm. And that is 2x cubed minus 53. From here, I'm going to simplify the left-hand side. 5 to the 0th power is 1. I have 1 is equal to 2x cubed minus 53. From here, I'm going to add 53 on both sides. So I'm going to add 53 on both sides of this equation. I'm going to end up with 2x cubed is equal to 54. I'm going to divide both sides by 2 to get that x cubed by itself, and eventually the x by itself. I'll have x cubed is equal to 27. Taking the cubed root of both sides, I'm going to see that I have x is equal to the cubed root of 27, which is 3. So my answer is x is equal to 3. For 31, I have a logarithm of a logarithm is equal to 2. Don't let this scare you. It's the same exact problem as we just did. This I can't solve in logarithm form, so I need to convert to exponential form. If I see a logarithm 2 times, a log inside of a log with a missing variable, I'm going to have to rewrite in exponential form 2 times. The first time I'm going to identify what's my base. My base is 3. So I'm changing this to 3 to my exponent is 2. It's always the number by itself on the other side. So 3 to the second power gives me the answer, and that's everything inside of the parentheses, not just the x, but the whole thing inside of the first logarithm on the outside. And that is log base 3 of x. From here, I'm going to evaluate what I have. 3 squared is 9. I have 9 is equal to log base 3 of x. And this is another logarithm. I can't solve in logarithm form, so I need to convert to exponential form. My base is 3, so I'm going to write my base is 3. My exponent is 9, so I'm doing, 3 to the 9th power gives me my answer, which is what's inside of the logarithm, x. So I know that x is 3 to the 9th power. I'm going to do 3 to the 9th power in my calculator, and I'm going to get that x is equal to 19,683, and that's my answer. All right, number 37, I have 9 to the log base 3 of 5 power. This also looks like the property, like the problem we did before. It looks like b raised to the log base b of x. I know that that's gonna give me what's inside of the logarithm. If I have a base raised to a logarithm with the same base, it's gonna be whatever is inside. This is a little bit wrong right now because I have 9 as the base and the exponential, and 3 as the base of that logarithm in the exponent. I can see, though, that 9 and 3 have a base in common, so I can actually rewrite 9. I can rewrite 9 in terms of 3 to some power. I can write 3 to the second power, that is. I have 3 to the second power raised to the log base 3 of 5. When I have a power to a power, I multiply the 2. So I multiply 2 times log base 3 of 5. I end up with 3 to the 2 log base 3 of 5. In the exponent, 2 log base 3 of 5, I want to change that so it doesn't have a coefficient. It doesn't have a coefficient here in the property. So I'm going to take that coefficient and I'm going to make it an exponent instead. I'm going to make it an exponent for what's inside of that logarithm. That's going to be 3 to the log base 3 of 5 squared. So inside of that logarithm, I have 5 squared. This tells me my answer is 5 squared, or 25. For number 38, I have 5 to the 3 log base 5 of 2 plus 2 log base 5 of 3. This is the same thing. It looks like it could potentially become b to the log base b of x, and I know that's going to be equal to whatever's inside of that single logarithm in the exponent. The base here is 5. I have a base of 5 for these two logarithms. They both have base 5, so I can combine them. Before I can combine them, I'm going to actually do this off to the side. I have 3 log base 5 of 2 plus 2 log base 5 of 3. And first thing I'm going to do is get rid of these coefficients. I'm going to make them exponents instead. I'm going to move them to be exponents of what's inside of the logarithm. That first logarithm is going to become log base 5 of 2/3. The second logarithm is going to become log base 5 of 3 to the second power. So I just moved those coefficients to be exponents. I have, this is, if I simplify further, log base 5 of 8 plus log base 5 of 9. And then I know because there's addition in between these two logarithms with the same base, I can combine them with multiplication. So I have log base 5 of 72. So this whole problem changes to 5 log base 5 of 72. I know my answer is 72. It's what's inside of that logarithm. All right, for 42, I have 3 logarithms with the same base. There's an issue with 2 of them. They have coefficients. I'm not allowed to have coefficients when I'm condensing in condensed form. So I'm going to move this 5 to be the exponent for y, and I'm going to move this 2 to be the exponent for 4 inside of those logarithms. I have log base 3 of x then minus log base 3 of y to the 5th power plus log base 3 of 4 to the 2nd power. From here, I'm going to end up with log base 3 of x minus, I'm sorry. I meant to, I'm going to combine these first two. I'm going to read from left to right. I'm going to combine that way. I see subtraction in between those first two. So I'm going to combine with division. I'm going to take the insides and divide them. I'll have log base 3 of x divided by y to the 5th power plus log base 3 of this is 4 squared is 16. From here, I'm going to combine these two. There's addition in between, so to combine their insides, I'm going to multiply. I'll have log base 3 of, I have 16 times x in the numerator, or x times 16, which is 16x, and then in the denominator, I have y to the 5th power. This is a single logarithm by itself with something inside. I have something inside of a single logarithm by itself. No coefficients, no fraction exponents. I'm finished. For 43, I have a bunch of logs with base a. So I'm going to be able to combine all of these. I'm going to always start with what's inside parentheses. So I'm going to start with what's inside parentheses there. What's inside parentheses, there's subtraction in between. I know I can combine with division. So I have log base a of x divided by y times 3. My first logarithm doesn't need to be changed. Log base a of 2x is good. I'm just going to put 2x in parentheses so I could more clearly see what's inside of the logarithm. Now I want to combine these two, but I have the problem of this coefficient that I need to get rid of. I'm going to move that coefficient to be an exponent, and when I do that, I need to make sure that I'm distributing it to be the exponent for both the x and for the y. Let me write this better. So I should have x over y cubed. I should be distributing this 3 to both the x and to the y. Don't forget to do that. So I'll have, log base a of 2x plus log base a of x cubed divided by y cubed. And now that I have that, I have 2 logarithms with the same base, addition in between. I'm going to be able to combine them with multiplication. So I have log base a of, I have 2x times x cubed. So I'm going to do this off to the side, times x cubed. That's a total of 3 plus 1, 4 x's multiplied to 2. So 2 times x to the 4th power. 2 times x to the 4th power divided by, in the denominator, I have y cubed. This is a single logarithm by itself, no coefficients, no fraction exponents, something inside, and I'm done. For 44, I have 3 logarithms with base 2. First thing I'm going to need to do, these all have problems of coefficients that I need to get rid of. So I need to take all of those coefficients and make them exponents of what's inside of the logarithms. I have, for the first logarithm, it's going to be log base 2 of 8 to the 2/3 power. The second one's going to be log base 2 of 9 to the 1/2 power. And the last one's going to be log base 2 of 4 to the 3rd power. 8 to the 2/3 power, I'm going to do this off to the side. 8 to the 2/3 power, that's the same as doing the raising 8 to the 2nd power and then taking the cubed root, the 3rd root of that. So I'm doing a to the second power is 64, and then taking the cubed root of 64. And if I do the cubed root of 64, which you can do in your calculator if you don't know what that is, and you'll get 4. So this is actually log base 2 of 4. Plus, I have log base 2 of 9 to the 1/2 power is the same as the square root of 9. Because I'm doing 9 to the first power and taking the second root, and that's 3. And then for the last one, I have log base 2 of 4 to the third power, which is 64. The next step, I'm going to start with reading left to right. I'm going to start by combining these two first. There's addition in between, so I can bring them together with multiplication. So I have log base 2 of 12. So I took these two to start. I combined them to be log base 2 of 12. I'm subtracting log base 2 of 64. Subtraction in between two logarithms with the same base. I combine them using division. I do a number in the first logarithm divided by the number in the second logarithm inside of that consolidated logarithm base 2. And then I simplify always at the end if I can. 12 divided by 64 simplifies to be, I can divide by 4 in the top and the bottom. So I have 3 over 16. And this is my final single logarithm by itself with something inside, no fraction exponents. I'm finished. I have 4 ln of x plus 2 ln of 3y. First thing I need to do is get rid of the coefficients. I need to get rid of these coefficients to be able to combine. I'm going to make them exponents instead. I'll have ln of x to the fourth power plus ln of 3y to the second power. I need to make sure I'm distributing that 2 to both the 3 and to the y, all factors inside of that logarithm. I'm going to have ln of x to the fourth power plus ln of 3 squared is 9, y squared is y squared. Now, these two logarithms have addition in between, so I'm going to combine them with multiplication. I'll have ln of x to the fourth power times 9y squared, and if I simplify that, it'll be ln of 9 times x to the fourth power, y squared, which I write without the multiplication sign. This is a single logarithm by itself with something inside, no fraction exponents. I'm finished. For number 49, I have ln of e to the fourth power plus log base 2 of 1 over 8. These two logarithms can be evaluated. Their base and what they have inside share a base in common. I'm going to start with ln of e to the fourth power. I like to rewrite ln as log, so I write log base e of e to the fourth power. I'm asking what do I have to raise e to get e to the fourth power? That's 4. And then I'm going to do log base 2 of 1 over 8. That's, I'm asking what do I have to raise 2 to get 1 over 8? I could do 2 to the x power gives me 1 over 8 and solve for what x is. These two sides share a base in common. That base is 2. The left-hand side just stays 2 to the x power. The right-hand side, I know that's 2 to the negative third power to get 1 over 8. So I have that if these two sides are equal, then x has to be negative 3. So this is 4. This is negative 3. I'm adding the 2. So I'm going to end up with 1 when I do that. The answer is 1. For 50, I have 3 logarithms. I'm going to combine them because they all have the same base. But first I have to get rid of the coefficients. I'm going to get rid of all the coefficients. I'm going to make them exponents instead. I'm moving these to be exponents. Moving these to be exponents. Make sure you make them exponents for everything inside of the logarithm. So I'll have, the first one will be log base 2 of, that's going to be a cubed, b cubed. The second is going to be log base 2 of b squared, c squared. And the last is going to be log base 2 of a to the fourth power, c to the fourth power. I'm going to start with these two, combining them. There's addition in between, so I'm going to combine their insides with multiplication. I'm going to have log base 2 of a cubed times b cubed times b squared. That's a total of 5 b's being multiplied together, so I have b to the fifth power. I have also included c squared. That's my what I'm going to get if I combine these two. I have that, I'm subtracting log base 2 of a to the 4th power, c to the 4th power from that. And now, since there's subtraction in between these two logarithms with the same base, I can do division to combine them. I'll have log base 2 of, in the numerator, I have a cubed b to the 5th power c squared divided by a to the 4th power c to the 4th power. When I'm finished, when I get to the end, I need to simplify if I can, whether that be giving an actual number or a fraction for the answer, or whether that be simplifying what's inside of the logarithm. In this case, I can simplify what's inside of the logarithm. I have 3 a's in the top and 4 a's in the bottom. That writes like this: a times a times a over a times a times a times a. I have, if I cancel things that I have in the top and the bottom, I'm left with 1a in the bottom. So what I'll end up with in terms of a, there will be 1a in the bottom. In terms of b, I only have b to the 5th power in the top. I only have b's in the top. I took care of my a's. Now I took care of my b's. I have 2 c's in the top and 4 c's in the bottom, which means I'm going to end up with 2 c's in the bottom if I cancel. And this is my final answer. It's a single logarithm by itself with something inside. Whoops. With something inside, no fraction exponents. I'm finished. For 53, I have log base b of 3x to the 4th power y squared. This is inside of the logarithm. I want to expand this. So I see division inside. I see division. So I'm going to separate with subtraction. I'm going to do log base b of the thing that's in the top, 3x to the 4th power, minus, log base b of what's in the bottom, y squared. From here, I'm going to break down as much as I can further. In the first logarithm, I have a factor of 3 and I have a bunch of x's. I'm going to just separate the constants and the x's. First, I'm going to end up with log base b of 3 plus log base b of x to the 4th power, because there's multiplication in between, so I separate with addition. The second logarithm, I can for this logarithm, I know that I have an exponent. I'm not allowed to have exponents in expanded form, so I need to move this exponent to be a coefficient instead. So I'm going to write 2 log base b of y that I'm subtracting. So that exponent became a coefficient. Now for this one is finished. I can't expand that any further. That's a factor by itself inside, no exponents. But the second one I can simplify a little further. It has an exponent here, and I can move that to be a coefficient because I'm not allowed to have exponents in expanded form. So I'll have, finally, log base b of 3 plus 4 log base b of x minus 2 log base b of y. And this is my answer. There's every one of these expanded form has a single factor inside of the logarithm by itself and no exponents. So you need to look that there is no multiplication or division inside anymore of the logarithms, and there's no exponents. For number 54, I have log of the 4th root of xy divided by z squared. The last thing I do when I'm condensing something is I take the fraction exponents and I change them to roots. So the first thing I'm going to do when I'm going to expanded form from condensed form is the exact opposite. I'm going to take my roots and make them fraction exponents instead. So the fraction exponent that I actually have here, I have xy over z squared raised to the, if I do the 4th root, I'm actually raising it to the 1/4 power. From there, no exponents are allowed in expanded form, so I need to take that exponent and I need to move it to be a coefficient instead. So I'm going to have, 1/4 times log of xy divided by z squared. From here, I see division in between. So I see division in between these two logarithms, which means I'm going to separate with subtraction. I'm going to keep the 1/4 on the outside, and I'm going to distribute it at the end. I'm going to just put a bracket for parentheses. I'll have log of xy, that's what's inside, or that's what I have in the numerator, and I'm going to subtract a log of what I have in the denominator, z squared. From here, I'm going to separate as much as I can inside before distributing that 1/4. I'll have 1/4 on the end. I want to make sure I bring that down. Log of xy, there is multiplication inside. There's multiplication happening between that x and that y. So I'm going to separate with addition. I'll have log of x plus log of y. So this became this. For this second logarithm, I have an exponent. I'm not allowed exponents in expanded form, so I'm going to move that to be my coefficient. I will have that I'm subtracting 2 log of z. Now inside I have I have logarithms as separated as I can make them with only one factor inside, no multiplication or division inside anymore. And now all I have to do is take the coefficient and distribute it to everything. And I'm going to end up with 1/4 log of x plus 1/4 log of y minus, that's 2 times 1/4, which is 2/4. That simplifies to be 1/2 log of z. And this is my final answer. For number 55, I have ln of the square root of 16x divided by a times b to the 3rd power. For this, not the whole thing is in a root, just the top. So the first thing I need to take care of is actually the division that's inside of this logarithm. I need to separate the top and the bottom. I do that with subtraction. So I do ln of the top, which is the square root of 16x, minus ln of the bottom, ab cubed. The top, I have ln of, I want to rewrite this root instead as a fraction exponent. I'm taking the second root, so that means that I'm actually raising 16x to the 1 divided by 2 power, so the 1/2 power, minus ln of, or actually I can change this in the step. I'm just going to leave it right now. ln of ab to the 3rd power. For this first logarithm that I have an exponent that I don't want because expanded form you're not allowed exponents, so I need to move it as a coefficient. I'm going to have 1/2 times ln of 16x minus ln of ab cubed. And now I'm going to take care of these logarithms separately. This one here is going to break down further. I have multiplication happening in between the factors inside. So I'm going to break that down into 1/2 times, and I'm going to put this in parentheses, ln of 16 plus ln of x. Since I have multiplication inside, I break down with addition. The other thing I have, this logarithm here, breaks down also with addition. I'm going to be subtracting, and I'm going to put this in parentheses so I don't forget to distribute that minus. I have ln of, a plus ln of b cubed inside. I'm just going to take this, the b cubed, I'm going to take that exponent away from the b, and I'm going to move it to the front. So I'm going to have 3 ln of b instead. I just want enough space, make sure I have enough space. I'm going to distribute this 1/2 to these two, and I'm going to distribute this negative to these two, and I'm going to end up with 1/2 ln of 16 plus 1/2 ln of x minus ln of a minus 3 ln of b. and there's no fraction exponents. Oh, sorry, that's not what I meant. There's no exponents, and this is as separated as it possibly can be. There's no multiplication or division inside, just single factors by themselves. For 56, I have log of 4x minus 2y. This originally on my review sheet paper said that it was not, like you couldn't break it down, but you actually can, because you can change what's inside to multiplication or division. In this case, you can change it to multiplication, and you can change it to multiplication because you can factor what's inside here. What's inside here, I can factor out a 2. I share a 2 in common between the 4x and the 2y. So I'm going to take out a 2. I'll have 2 times 2x minus y. And that's what's inside of the logarithm. And what I can do from here is, because there's multiplication inside of the logarithm now, I can break it down with addition. So I'll do log of 2 plus log of 2x minus y. And this is my answer. I can't separate this any further. There's no factoring I can do there. It's just subtraction in between. You cannot break down subtraction inside of the logarithm. All right, for number 57, I have log of x divided by y cubed. This is division inside of that logarithm, so I separate with subtraction. I do log of x minus log of y cubed. From here, there's one more thing I need to fix. I'm not allowed to have exponents in exponential form, so I'm going to take this exponent and I'm going to move it to be a coefficient instead. I'm going to have 3 log of y that I'm subtracting from log of x, and this is my final answer. If I look inside of the logarithms, I only have a factor by itself, no multiplication or division, and I don't have any exponents. For 58, I have log base 3 of what's inside x cubed times the square root of y. There's multiplication inside, so I'm going to separate with addition. I'm going to do log base 3 of x cubed plus log base 3 of the square root of y. I can still expand further. I'm not allowed to have exponents in expanded form, so that exponent of 3 is going to move to the front. Another way that you could think about that is if you can't remember that property, you need only a single factor by itself inside. This is actually log base 3 of x times x times x. I can break down into log base 3 of x plus log base 3 of x plus log base 3 of x. If I combine that, that's 3 log base 3 of x's. So if you can't remember the property, you can think about it that way. You need single factors by themselves inside of the logarithm. So I have 3 log base 3 of x. I moved this exponent to be the coefficient instead. Plus, I want to rewrite this so that it doesn't have a root inside, but a fraction exponent. So I have log base 3, because I know what to do with exponents to get rid of them. This is technically an exponent here I need to get rid of, so first I need to rewrite that root as an exponent so I know how to get rid of it. This is actually y to the 1/2 power. Now I'm going to take this 1/2 and I'm going to move it to be the coefficient instead. And I'm going to have 1/2 log base 3 of y that I'm adding to 3 log base 3 of x. And this is my final answer. Inside of my logarithms, I should make that a little less sloppy. Inside of my logarithms, I have a single factor by itself, and I don't have any exponents, so it's good expanded form. It's as separated as it can be. And then for 59, I have a bunch of multiplication happening inside here, so I can separate with addition. I could do log of 2 plus log of x cubed plus log of the square root of y. And then I can fix everything that needs to be fixed. I'm not allowed to have exponents. This is an exponent. This is technically an exponent. I'm moving this to the front because it's already an exponent. That's clear for me to see. I have 3 log of x that this turns into. The log of 2 is fine. I don't need to change it. And then my last logarithm, I need to first change that square root to a fraction exponent. That's y to the 1/2 power. So I have an exponent that I can now move to be a coefficient instead, because no exponents in expanded form. Now I have 1/2 log of y, log of 2 plus 3 log of x plus 1/2 log of y. I have in every single one of these just one single factor by itself. So this is as separated as it can be. There's no exponents. I'm finished. This is expanded form.